Welcome to this explainer. Today, we're bringing some serious energy to uncover the absolute truth behind how neural networks actually work. It brings up a massive question. When we say a neural network learns, what is actually happening inside it? People often imagine AI as having this magical spark of human understanding, but we're going to instantly demystify that entire process for you right now. Okay, let's dive into this. Because honestly, there's absolutely no magic involved here. No sudden aha moment of understanding. There's really just a loop. A simple, relentless, mechanical loop of guessing, checking, and adjusting. To get a handle on this loop, we have to look at the very foundation of the model, its parameters. You probably already know these as the model's weights, but visually just picture them as tiny, adjustable knobs. Their exact settings entirely dictate how the model behaves. And guys, I mean, a lot of knobs. We're talking millions, sometimes billions of them. The whole concept of training in AI, it's literally just the process of finding the exact, perfect setting for all those millions of tiny knobs. But right at the beginning, before any training even happens, all those knobs are set completely at random. This means the model is, well, practically useless right out of the gate. It's just spitting out absolute nonsense. So, how do we fix that? Well, that's exactly where our humble loop begins. Here's our roadmap for the process, broken down into 3 super simple stages. Step 1 is guess, step 2 is check, and step 3 is adjust. Let's walk through exactly how this plays out. It all kicks off with step 1. The model is given a training example, and it just makes a prediction, like it looks at a photo and guesses cat, but the correct answer is actually dog. Now, what's really interesting about this slide is how we handle that mistake in step 2. We measure exactly how wrong the guess was. This measurement is called the loss. Think of it as a single mathematical number that captures the precise size of the model's error. It's a beautifully simple rule. A big mistake means a big loss. And the entire goal of this massive, computationally heavy training process is simply to make that loss number as small as humanly possible. Which brings us to step 3. And this is where things get really clever. It's called backpropagation. Basically, the model traces its steps backwards from its mistake to figure out exactly which knobs were responsible for the error. It's trying to find out which way to nudge each individual knob so that it shrinks that mistake next time around. To figure out that perfect nudge, the system relies on the gradient. The gradient is just the exact mathematical calculation telling it which direction and exactly how much to turn every single one of those millions of knobs. Once the math is done, the system actually takes action. It adjusts the knobs based on that calculation. That tiny adjustment, actually taking a small step in the calculated direction, is what we call gradient descent. And this brilliantly illustrates what all this complex math actually feels like in practice. I want you to picture standing on a super foggy hillside, trying desperately to reach the valley floor below. Imagine you're completely blindfolded. You absolutely cannot see the landscape around you, but you can feel which way the ground slopes right under your feet, so you just take one small step downhill. Tying this metaphor right back to the math, your altitude on that hill is the loss. Every single time you take a step down that slope, you lower your altitude just a little bit. You're shrinking that loss. Then you just repeat the process. Feel the slope again. Take another step. Eventually, by simply following the downward slope step by step, you're inevitably going to arrive right at the very bottom of the valley. And you know what? That is the entire secret to neural networks. It's literally just running through these tiny, kind of unimpressive individual steps over and over. Guess, measure the error, figure out which way to nudge every knob, take a tiny step, and repeat. The real magic here is simply the scale. It has to repeat this exact loop millions upon millions of times over massive amounts of data for the process to actually work. So the crucial point is this: no single step is impressive on its own. But if you run that humble loop long enough, suddenly a massive pile of random numbers gradually organizes itself to recognize faces, translate languages, or even hold a totally fluid conversation with you. It's wild. It leaves us with this incredibly powerful thought to end on today. Learning for a machine is just error made a little smaller over and over and over. Which begs the ultimate question. As these models get exponentially larger, is human intelligence really that different? Are we just running our own humble loop? Thanks so much for joining me for this explainer. Catch you next time.